take a look at some trigonometry today. We're going to be splashing back and forth between Swedish and English, so I apologize in the beginning. But when we're thinking of trigonometry, we should think of right triangles, eller rättvinklig trianglar på svenska, and we should think of the three different ways to calculate an angle using sine, cosine, and tan. Och på svenska vi har sin, cosine och tan också. So up to the left we see that we have this funny looking word, SOHCAHTOA. It means that the sine of an angle A, for example, this angle, will be equal to the opposite side, A, divided with the hypotenuse, and so further. We have a couple special triangles we can imagine. If we fill out this triangle, a square with sides 1. Well, to calculate that middle side, you can use Pythagoras sets or Pythagorean theorem to find it out. So it's going to be equal to 1 squared plus 1 squared, and then take the root of that. So you're going to have the root of 2. So we have a special triangle, 1, 1, root 2, or we say the 45, 45 triangle. The other triangle we have is the 30, 60, 90 triangle. 30 degrees is the smallest angle. So we have the smallest side 1. The largest angle is 90. So across from that will be the largest side, which will be 2. And if we use Pythagorean's theorem, we can solve that this side will be root 3. And in your free time, you can go ahead and try to test that. So we do have two special triangles. We have the 45, 45 triangle. And we have the 30, 60, 90 triangle. So these are really good to remember because, for example, someone comes to you on the street and says, hey, what's the sine of 45? Well, you can look at this triangle and say, well, the sine of 45 will be the opposite divided by the hypotenuse. So the sine of 45 is actually equal to 1 over root 2. Someone asked you, hey, what's the cos of 60 degrees? Well, the cos of any angle will be the adjacent side divided with the hypotenuse. So the cos of 60 will be 1 divided by the hypotenuse 2. So these are very helpful to have. You don't need a calculator. You can just remember these two triangles. So these help us decide the ratio between the two sides of a right angle triangle, and it helps us to evaluate the value of an angle when we take the sine of an angle, the cos of an angle, and the tan of an angle between 0 and 90 degrees. So if we look down further, we also can find that these triangles will also satisfy the demand for if we have another value for our hypotenuse where we see the values of the 30, 60, 90 still exist. And also in another example, we might have the 45, 45 triangle. And we can still use what we know from these special two triangles to solve the opposite sides. So for example, we take a peek here at the first triangle. We know that we see that these two sides should be equal. So someone can write in 3 here. And to find that final third side, we can also use Pythagorean's theorem. Or by knowing that it should be root 2 times x. In this case, x is 3. It'll be 3 root 2. So we can rewrite that as 3 root 2. When we have sides 3, we can determine the other remaining sides by calculating if x is 3, then the side that's going up vertically will be the root of 3 times x, which will be 3. So we can actually write it like that, or better, we can write actually 3 root 3. And the hypotenuse will always be 2 times x. In this case, x is 3, so we can say it's 2 times 3, which will be 6.
Let's check it out. Ah! Whoa, what's the matter?
What the hell is that? A killer robot monster? Ah!
Stewie, relax.
No, Brian, you keep that thing away from me. Is it looking at me? Can it see me?
Man, you're really scared of this thing, huh?
Ah!
So now we're taking a look at this scary looking circle. This is actually called a unit circle, or på svenska vi säger an enhetscirkel. And we have to imagine that we have a circle with a radius of 1. And we can determine we have 0 degrees along our x-axis. And as we go up towards the top of the graph, we see that we reach 90 degrees. And as we continue around, we see that we have 180 degrees, 270 degrees, and we're back to 360 degrees just before the x-axis, or else we'll be back to the beginning. So we can take one complete lap around this circle, and we will reach the point of 360 degrees. This circle is helpful for identifying the values of different combinations of sine, cos, and tan of a certain angle. So let's take a look at sine of 30. So what we can do is we can look at where does 30 exist on this circle. And we see that sine of 30, we can measure if we draw a line from the origin all the way up to something like this. And we can determine the sine of this by imagining that we have an xy coordinate. So we can say the x coordinate will be, if we look along the x-axis, something about here. So maybe we can say like a roughly 0.9. And we can also say that there's a y value as well. If we go along the y-axis, and we see that it's about 0.5. So we have an x value and a y value. And what this is going to help us with is it's going to help us determine the sine of this angle. Obviously, we can calculate the sine of 30 using our special triangle. So the 30, 60, 90 triangle. But also using the unit circle, we can also determine. So if we determine that we have the sine of 30 degrees, we need to take the opposite side, or på svenska vi säger motstående sida, eller katet, divided by the hypotenuse, or hypotenusa. So from sine of 30, we're going to look at the opposite side. How much do we go up along the y-axis? Well, that was 0.5. And remember that we have a radius of 1 along this circle. So any line going from the origin all the way to the edge of the circle will be a value of 1. So this is the same value as 0.5. And let's just double check with our special triangle. Remember, we had the special triangle where we had 30, 60, 90. Remember the smallest angle with the smallest side, then the largest angle with the largest side, and the remaining is the root of 3. The sine of 30 will be the opposite. So which is 1, and divided by the hypotenuse will be 2, which is also the same as 0.5. So we see that there's 2 different ways we can also calculate the sine of 30. By looking at the unit circle, we can also determine that there's 2 answers to the sine of 30. And we need to look into the second quadrant to the left. So this is called quadrant 2. And what we need to do is we need to look at, to find the sine of 30, the sine of 30 will also be equal to the sine of 180. Sine of 180 minus 30. And which will equal the sine of 150. So if we look at the 180 along the x-axis, we go up 30 degrees, we'll end up at 150. So we take ourselves 30 degrees from the x-axis. Well, we can determine that this has a coordinate as well. Remember, if we imagine this going two directions, along the x-axis, we have a negative version of maybe 0. I estimated 0.9 earlier, so we can keep 0.9. So that's 30 degrees that way. So we have the coordinate 0.9 negative and up. Well, it's going to be the same. It's going to be 0.5 as well. And to find the sine of this angle, well, it would be the opposite, which is the y value, 0.5, divided by the hypotenuse. So it is true always that we have the sine of some angle x will always be equal to the sine of 180 degrees minus x. Always. Now let's take a look at the cos of 145 degrees. So first let's find where 145 degrees will be. And we're going to see that it's going to be between 140 and 150. So maybe we can say roughly there. And what we can do is we can imagine that we are drawing a line from the origin to that point. So it's going to be about 35 degrees from 180 degrees when we take it away. Let's fix that a bit. Something like that. There. So we can also find the value of this by calculating how many degrees are we away from the y-axis. And what I mean by that is x-axis. So now to determine the value of this by using the circle, we can determine how far did we move up away from the x-axis. And we can do that by taking 180 minus 145. And we'll end up with 35 degrees. This is going to be 35 degrees. Again, we can determine the cos of this by imagining that this forms a nice right triangle. And so what we can do is we can take the cos of 145 will be the adjacent side divided by the hypotenuse. And in Swedish, we say that we take the närliggande katet delar med hypotenusa. The hypotenuse will always be 1 because of the radius of the circle is 1. And to find the adjacent side, we need to find the value of the side of this triangle that's lying on the x-axis. In this case, we can say it's roughly negative 0.85 maybe. So we got negative 0.85. So we have negative 0.85 as a coordinate along the x-axis. And along the y-axis, we go up. We can say it's roughly maybe a little more than 0.5, so maybe 0.55. If we go across, roughly here. So let's make that nicer, 0.55. And so we can calculate the cos of this angle would be the cos of this 35 from what we see in this triangle. So we're going to take the adjacent, so it'd be negative 0.85 divided by the hypotenuse. So our answer is going to be negative 0.855, roughly, or negative 0.85. Like we did earlier, this could be also said that we have two possible answers. And what I mean by this is that the cos of some angle x will also be equal to the cos of the negative x. And basically what this means is that the cos of x will be equal to the cos of, when we take this value or this angle away from 360. So imagine we started at 360 and we went back this way as much as the angle that we had. So we're going to say that the cos of 145 will also be equal to the cos of 360 minus 145. And so we're going to end up having, let's do some quick math here. So 215 degrees. So the cos of 145 will also be equal to the cos of 215. And we can also see that 215 will be roughly here. We'll just estimate. And what you should notice is that the angle between, take this away, the angle between 180 to 145 was 35 degrees. And also maybe you see the relationship now, the angle between these two will also be 35 degrees because 215 minus 180 will give you 35. So that means we can imagine another line coming from there. $35 degrees, same thing. We can imagine that we have a right triangle. So it's true that the cos of 145 will also be equal to the cos of 215. So at this point, we will look at our third example down to the left, where we take the tan of 230 degrees. First thing we need to know is, how do we calculate the tan of an angle? And it's going to be equal to the opposite side of a right angle triangle divided with the adjacent side. We can remember also TOA, SOHCAHTOA. That's easy to remember which side you're going to calculate. And in Swedish, we say the motstående katet delar med närliggande katet. So 230 degrees along the circle, we find it is here. And so we can also imagine that from the origin, we draw a line. We saw that was 50 degrees angle, but we can also calculate this by taking it. If we imagine how much did we go from the x-axis, or 180 degrees, we could do the difference between 230 minus 180, and you should get 50 degrees. Like we did previously, we can imagine that this point on the graph has an x and a y coordinate. Actually, we can draw it in here. The x coordinate will be along the x-axis. We can see if we go up, it's about negative 0.65. And along the y-axis, we can imagine if we look along, we have about negative 0.75. Negative 0.75. And if we calculate, here's our right triangle. We have hypotenuse 1. If we calculate the relationship of tan to this angle 230, we're really taking the tan of 50 here. So we're going to use the opposite side, which would be along our y-axis. So we take the y coordinate, so negative 0.75, and we're going to divide that by the adjacent side, which would be our side along the x-axis, which would be negative 0.65. And so when we take two negative numbers and we take to find the quotient of these, we know that it's going to be a positive answer. So our answer will be 0.75 divided by 0.65. We can also find a similar answer by using the rule where we have tan of some angle x will also be equal to tan of that angle plus 180 degrees. So we can also think about if we start from 230 degrees and we want to go 180 degrees further, you can add those together and find the sum. Or when you think of a circle, you should imagine that 180 degrees will be halfway around the circle. So if we started at 230, well, the opposite, not the opposite, I mean the 180 degrees will be exactly the other way. So if we imagine the line going right to there, and we can see that it'll be at 50 degrees. So our angle will be 50 degrees. To double check, you can also say the tan of 230 degrees will also be equal to the tan of 230 plus 180. You can also see like one whole lap will get you to 360, and it takes you 50 more degrees to reach that point. So 360 plus 50 will give you 410. So the tan of 230 will also equal the tan. Oh, that's not looking too nice. Let's fix that up. The tan of 230 degrees. And we can also look at the coordinates. Here, I'll make that a little smaller. So the coordinates of that point up there, well, we have to look at the x-axis and the y-axis. So let's zoom in. So we got 0.65 as an x value. And for our y value, say it's about here, we got 0.75. Very same values as below. So the tan of, in this case, the tan of 410 degrees, well, actually, we're looking at the tan of 50, according to our circle here. And that's going to be equal to the opposite, which will be our y coordinate first. So this will be our opposite. And our adjacent will be the x-axis this time. The adjacent will be 0.65. And there's no simplifying here because we have two positive numbers, whereas before we had the two negative numbers. And one should see that we get the same answer. So it's always true that the tan of some angle, x, will be equal to the tan of that angle, x, plus 180 degrees. So our final example, we're going to look at, we're going to find the angle of the coordinates 0.6 and negative 0.8. Again, this is the unit circle that I've created. It's pretty damn close to being exact. However, if you were able to check some of these values with your calculator, we might be off just a tad, but this is just down to based on rounding our values. So let's take a look at this one here. So we got x value of x value of 0.6 right here, and the y value of negative 0.8. And we need to see where they meet. So let's just zoom in to this quadrant. And as we go down this way, we see that they meet at this point here. It looks like it's almost between 300 and 310. So maybe around 305 degrees is our estimate at this point. So I hope this video is helpful of getting a better idea of how to use the unit circle, why it's helpful, and also I hope that it was helpful to see the two special triangles that we were able to use to calculate. We can use the first triangle, the 45-45 triangle. It helps us with finding the sine, cos, and tan of 45. And we also know that we have the second special triangle, the 30-60-90. This is able to help us calculate the ratio between the two sides of a triangle and its angle when the angle is 30, 60, or 90 degrees. So thanks for tuning in today. Hope this video was helpful, and hopefully you don't have a huge headache by now. Thanks, and take care.